Until recently, the only way to enter our office was with RFID tag. They changed it when our administrative director, Alexander Lyakov, a professor of computer science and machine learning department of Poltava Polytechnic University, brought our team together and proposed developing a facial recognition-based access system. The system is designed to process live video, detecting real faces, while ignoring static images like photos. We really like the idea, and the company provides all necessary equipment. So, we go to work. I was responsible for the software side of the project. I developed the system in Python, using libraries such as OpenCV, face recognition, dlib, NumPy, and scikit-learn, optimizing to run it efficiently on a Raspberry Pi 5 by adapting and fine-tuning standard face detection and recognition algorithms. I was able to achieve reliable real-time performance and seamless door access control. The development and testing process took almost 4 months.
Our next task was to build a dataset that would enable the system to reliably recognize employees while filtering out unknown individuals. Because the system operates in real-world and dynamic conditions, we had to carefully design the dataset, selecting the optimal number of samples per person, varying head positions and facial expressions, adjusting distances to the camera, and choosing appropriate hardware.
This involved extensive testing and iteration. The dataset development and model training process took around 3 months.
Once the software and algorithms were ready, we moved on to assembling and installing the hardware at the office entrance. The main challenge, however, was integrating our system into the existing security infrastructure. Since this required expertise beyond our core competencies, Alexander brought in a colleague to help us. Bogdan gladly joined the project and played a key role in the integration process.
My profile is device engineering, and this was a really interesting challenge for me. I was responsible for design of enclosure and integration Raspberry Pi motion sensor, camera lighting into a single unit. It was also interesting to design the system with security in mind, preventing any possibility of brute force access. The audio unit is effectively hack-proof since it doesn't rely on any external communication protocols.
The system is now fully assembled, integrated into the office security system, and operating in real conditions. From the internal concept to fully refined solution, the entire process took about 6 months. And here's how it works. Like any real project, we faced multiple challenges, from selecting the platform and designing the enclosure to training AI and optimizing performance.
The facial recognition system we developed for our office can also be used in other locations. We've come up with a few ideas for places where this system would be incredibly convenient. Take our private courtyard, for example. Currently, residents enter the courtyard using an RFID tag, but to make it much more easier and safer, we could use our facial recognition system for entry. In the same way, by updating our system, we can allow vehicles to enter based on license plate recognition, which would be much more convenient than the current method where residents use a remote control to open the gate.
The system logs every visitor and records the exact time they entered the office. In the future, we plan to store images of individuals with denied access and, in the case of repeated attempts, automatically send a notification with their photo via a notification service.